Hey everyone, and welcome. We are jumping right into something I'm super excited about today, mainly because we're going to untangle a really massive knot in the nutrition world. We're talking about two of the most infamous plant-based dietary villains out there, gluten and lectins. If you've spent, any time at all reading about gut health or inflammatory diets, you've absolutely heard these names thrown around, often in the exact same sentence. But today, we're cutting through the noise to look at the hard biology. We're going to break down what they actually are, how they behave in your body, and most importantly, clear up the wild amount of confusion surrounding them. The big question that kicks this all off is simply this. Are gluten and lectins the exact same threat? Because they both notoriously hang out in whole wheat, people constantly lump them together. It's incredibly common to hear diet advice that treats them like identical twins of dietary destruction. You'll hear things like, oh, you have to avoid wheat because of the gluten and the lectins, which naturally makes us wonder if they're actually posing the same kind of danger to our bodies. Well, when we strip away all the dietary buzzwords and the marketing hype, science gives us a very clear, hard no. Biologically and functionally, they are entirely different proteins. They don't look the same under a microscope, they don't act the same in a petri dish, and as we're going to see, they absolutely do not behave the same way once they travel down your digestive tract. Okay, let's dive right into our roadmap for this explainer. We'll hit the dietary villain mix-up, the breakdown, the battle inside the gut, the anatomy of a wheat grain, and finally, the real inflammatory threat. All right, starting off with Section 1, the dietary villain mix-up. So why exactly is the internet so convinced that gluten and lectins are partners in crime? Honestly, it really comes down to real estate. Both of these proteins are labeled as plant-based villains, and crucially, both are found in some of the most common foods we eat globally, specifically wheat. Think about it. If you eat a standard slice of whole wheat bread, you're consuming both gluten and a very specific wheat lectin known as wheat germ agglutinin, or WGA. Because they're delivered in the exact same package, literally the slice of toast you had for breakfast, it creates this incredibly convincing illusion that they're the same thing, or at least working together. Section 2. Gluten versus lectins, the breakdown. But here's the thing, they aren't working together, and they really aren't the same. Let's look at a direct side-by-side comparison of the raw biology. Now, what's fascinating here is the sheer contrast. Think about gluten first. Its primary food sources are actually very specific: wheat, barley, rye, and sometimes cross-contaminated oats. And its immune impact? It can be severe, triggering a highly specific autoimmune reaction in people with celiac disease. Now switch gears and look at lectins. Their food sources are vastly different. We're talking legumes like beans and lentils, all sorts of grains, nightshades, nuts, the whole shebang. But their immune impact? They primarily act as a local digestive irritant, and that is only if they're eaten completely raw. So we have a highly specific autoimmune trigger on one hand and a widespread, mostly raw state irritant on the other. Completely different. Moving right along to Section 3, battle inside the gut. So what actually happens when we swallow these proteins? This analogy brilliantly illustrates the mechanical difference between the two. When we talk about gluten, we're talking about a lock and key trigger. It literally requires a specific genetic lock to cause its most famous damage. Lectins, on the other hand, act way more like a sticky note. They rely on a simple, physical, carbohydrate-binding nature. They don't need a genetic lock at all. They just need a surface to stick to. Let's look a little closer at that lock and key mechanism. For the vast majority of us, gluten is definitely tough to digest, but it pretty much just passes through the system. However, in individuals with celiac disease or non-celiac gluten sensitivity, the immune system is genetically primed to react. The adaptive immune system actually mistakes these undigested gluten fragments for a dangerous invader. It launches this severe assault on the microvilli. Those are the tiny hair-like structures lining your small intestine, flattening them out and destroying the gut's ability to absorb nutrients. It is a targeted, systemic, and very serious reaction. Now let's contrast that with our sticky note. Lectins do not care about your genetic profile. They're chemically drawn to the sugar molecules that naturally coat the cells of our digestive tract. If you consume raw lectins, they physically bind to the gut wall, just like Velcro. And yeah, this causes acute digestive distress. Seriously, if anyone here has ever had the absolute misery of eating undercooked or raw kidney beans, you know exactly what I'm talking about. It leads to swift and frankly violent vomiting. But notice the mechanism here. It's a physical, local irritation caused by stickiness. It is not a systemic autoimmune attack. Section 4. Anatomy of a wheat grain. To really cement why we need to treat these differently in our diets, let's look at the architecture of wheat itself. Where do they physically hide? Well, a massive 83% of the grain is the endosperm. That's the starchy white interior. And that is exactly where the gluten dominates. But consider the outer layers, the bran at 14% and the germ at just 3%. These areas are the nutrient-dense armor and the embryo of the seed, and this is where the lectins, specifically WGA, are highly concentrated. They literally live in totally different neighborhoods of the exact same grain.
So the absolutely crucial point here is what happens during processing. When we make standard white flour, we strip away the bran and the germ. And what does that mean? It means we strip away the lectins. White flour has virtually zero lectins, but it is absolutely packed with gluten from the endosperm. Whole wheat flour, which keeps the entire grain intact, gives you both. This perfectly illustrates why these proteins are uncoupled. You could easily consume a diet terribly high in gluten while consuming almost no wheat lectins at all.
Which leads us to the climax of our explainer, Section 5, the real inflammatory threat.
Okay, it's time to definitively separate a managed threat from a true autoimmune driver based on the clinical evidence. Let's start by defining a managed threat. This is a biological irritant whose harmful properties are easily neutralized by everyday cooking. Heat literally changes its shape, rendering it completely inactive. And guys, this is exactly what lectins are. Because they're heat sensitive, the standard ways we prepare food, boiling, soaking, pressure cooking, neutralize them completely. They lose their stickiness. That means a plate of properly cooked beans or grains contains almost zero active lectins. You manage the threat simply by making your food edible.
But contrast that with gluten. Gluten is heat stable. You literally cannot cook the danger out of it. Whether you bake it, boil it, toast it, or fry it, the structural proteins of gluten do not break down. The heat does not change its shape in a way that stops the immune system from recognizing it. It remains active and incredibly potent in whatever baked good you pull out of that oven. And because of this heat stability, combined with its lock-and-key interaction with the immune system, the clinical evidence is incredibly clear. For those with diagnosed autoimmune conditions like celiac disease or even things like rheumatoid arthritis, gluten acts as a systemic inflammatory driver. It's not just a temporary upset stomach, it's an evidence-backed trigger that initiates a massive cascade of systemic inflammation throughout the entire body. So I want to leave you with this provocative thought. Are we overstressing managed threats while completely ignoring true systemic drivers? When we panic over lectins, which again, a simple boiling pot of water neutralizes, are we just wasting our dietary anxiety? By understanding the clear biological and clinical distinctions we cover today, you are now empowered to focus your attention where the science actually points. Thank you so much for joining me to explore this one. Keep asking questions, keep looking at the data, and I'll catch you in the next explainer.